All right, welcome back everyone. This is Noah, and in this video we're going to go ahead and run through the solutions to the now you try problems. We're graphing a quadratic function given in vertex form. All right, so given the following functions, given in vertex form, a little redundant there, find the vertex y-intercept, y-intercept's mirror point, the x-intercepts, and 2 additional points, then graph the function. Let's see if in these we get something that actually has some x-intercepts. Unlike those examples, I think that we will. Yeah, we definitely will. All right, just clearing some space out to graph this first one and everything. F of x equals -2 times x plus 3 quantity squared plus 5. So we start with noting the vertex. Vertex is the point -3, +5. The y stretch is -2, so this is opening down. Note that. And let's get that y-intercept. If I plug in 0 for x, we'll get -2 times 3 squared is 9. Let's do one more step there. 3 squared, and we'll add 5. This will be -2 times 9 plus 5. So that's going to be a -18. Plus 5 is -13. So our y-intercept is the point 0, -13. And let's see, let's go ahead and start graphing here. I'll give myself plenty of space to the right. And the vertex is positive, the y-intercept's negative. The vertex is up at 5, we're downward facing. I need a little bit of room up top, but not a ton. The vertex is -3, so I want to have this out to the left more than to the right. So let's do 1s in the y direction. So this is 4. And let's do 1/2 in the x direction. So -2 is out at the 4th location. And -4. Cool. So -3, +5 is going to be up here in the second quadrant, -3, 5. And the y-intercept is down at 0, -13. So let's see, there's -4, -8, -12, and right there, let's give myself a little bit more room down here. Here we've got the point 0, -13 on the y-axis. And so let's be careful. Let's see our axis of symmetry. Here we've got a distance of, well, it's -3 units. It's 6 grid lines. So I want to go another 6 grid lines out to the left to this point at -6, -13. So the y-intercept mirror is -6, -13. You can see that this x value there is always twice the vertex's x value every time. Cool. We need the x-intercepts, and I did manage to not give myself enough space. Let's see if I can't shift this over effectively. Is that okay? Is that on the grid lines? Close. That's better. Yeah, that's pretty good. All right. X-intercepts. So I'm going to set 0 equal to the function 0 equals -2 times x plus 3 quantity squared plus 5. I'll subtract the 5 over to the other side, so -5 equals -2 times x plus 3 squared. I'll divide off the -2 from both sides. So we get 5/2 equals x plus 3 quantities squared. And then we can take the square root of both sides. When we take that square root, make sure and get that plus or minus in there. So we get plus or minus the square root of 5 over 2 equals x plus 3. We're going to subtract 3 from both sides. Pause the video if you need to. I know I feel like I might be going a little bit fast. It's going to be -3 plus or minus the square root of 5/2. See how I have that square root coming all the way down there? I want to completely cover up that 5/2. It's not just the square root of the 5 on top. It's of the whole fraction. This equals x. I'm going to come off to the side for a brief moment here. And I want to look at that square root of 5/2 a little bit closer. If I multiply this, top and bottom, by the square root of 2, we will rationalize the denominator. What happens when I do this is I get on top the square root of 10. 5 times 2 is 10. On the bottom, the square root of 2 times the square root of 2 is just a 2. So I could rewrite the x-intercepts as -3 plus or minus the square root of 10 over 2, like that. Now, I'm not using a calculator here, and I'm going to continue to not use a calculator. So I don't know how to plot these yet, and I'm going to show you guys a nice way of kind of skirting what these values actually are for a second, in order to still be able to plot them. And to do that, what I actually want to do is I'm going to plug in like some points that are to either side of the vertex. Like we've got some space in here between the points that we have shown. So I'm going to plug in 2 more x values, or at least 1 more, and get its mirror point. Let's start with like -1, right? If I plug in -1, I want to see what y value I get. So if I go f of -1, I'm going to get -2 times -1 plus 3 is 2 squared, and then plus 5. 2 squared is 4 times -2 is -8. So I need to add that 5, so this is -3. So we get the point -1, -3 is here. And this is going to have a mirror across that axis of symmetry there. So this is the point -5, -3. So this is nice. This actually cleans things up pretty well. If I'm really careful, I can draw the graph already. But let's go ahead and just plug in another point just to really make sure that we're getting this correct. It's all about caring about having a nice picture in the end. So to do that, I'm going to say f of -2. I haven't plugged in -2 yet, so I'll get -2 times -2 plus 3 from the equation is a 1 squared, and then we'll do plus 5. So it'll be -2 plus 5 is positive 3. So that's going to give us this point, -2 positive 3, and it's going to have a mirror point at -4 positive 3. Now I'll draw my graph. Make sure it's a U-shaped parabola, not a V-shape. And watch what happens here. So I'm ignoring the x-intercept values that I found before completely right now, yeah? Just not worrying about them. And then what we'll do I'm super careful about being symmetrical when I'm doing this. So this is y equals f of x, and those x-intercepts, they are right here. So I don't even need to know what those approximations are. I mean, I could plug that into a calculator and figure out what it is, but they should be about negative 1.4 and negative 4.6-ish, give or take, so that it fits the graph nicely. But specifically, this is negative 3 plus the square root of 10 over 2, and negative 3 minus the square root of 10 over 2. Let's write these as points. Comma 0 for both of them. So when I have negative 3, that negative 3, this is the axis of symmetry. And then from that axis of symmetry, we're adding root 10 over 2 or subtracting it. So the point on the right is the negative 3 plus the square root of 10 over 2, comma 0. The point on the left is negative 3 minus the square root of 10 over 2, comma 0. So without even knowing exactly what those numbers are, well, I mean, those are the exact values, but without getting decimal approximations, we can still plot those points. All right. Nice job, everyone. Function squared minus 2. Start with our vertex. The vertex is the point positive 4, comma negative 2. This opens up with the y stretch equaling 2/3. And let's plug in 0 for x to get the y-intercept. G of 0 equals 2/3 times negative 4 squared minus 2. This will be 2/3 times, this is a 16 over 1, and then minus 2. This is going to be 32 over 3 minus, I want a common denominator, which has to be a 3. So if that's a 2 over 1, I'll multiply top and bottom by 3 to get a 6 over 3 there. 32 over 3 minus 6/3 is going to give us 26 over 3. And getting this as a mixed number is nice. This is going to be 3 goes into 26. 3 times 8 is 24. This is 8 and then 2 left over to get to 26. So 8 and 2/3. All right. So let's start graphing this. The vertex is at 4, negative 2. The y-intercept is at 8 and 2/3. Let's see. I'll make this pretty big here. Negative 2. All right, so if I just do 1s in the x direction, but then I'm going to do by 1/3 in the y direction. So got 2, 3, 4. Maybe that's too ambitious to try and go by thirds there, because I would need 26 thirds total to get to that y-intercept. All right, let's do that. This is 2, 4, 6, and 8. That'll be okay. I guess that's actually even more confusing. We can do that. So this is me really trying to think of like what's the best strategy here for making this work out nicely. And those thirds are a little obnoxious, right? Like if this is 2, then 1 is right here. This is 2/3 and that's 1/3. Right, because in 2 we want 6 total. This is 4/3, 5/3, 6/3. 5 4/3. This is 3/3. It's 1, right? So seeing that scale is really helpful for us. All right, let's not worry about that. Let's just go by 1s in the y direction. We'll keep this nice and simple as far as that. So we're not going to worry about that. Here's -3, -6, 3, 6, 9. So this is taller than it needs to be now, but that's okay. Nothing wrong with that. So the vertex 4, -2 is going to be here. This is opening up, so I can label underneath it. I actually think about that a lot. So is it 4, -2? I know the graph is going to go up, so I know I can draw underneath it, and I'm not going to get in the way of the graph. Now we want the y-intercept 8 2/3. So 8's right there. 8 2/3 is 2/3 the way up to 9. So 0, 8 2/3. And then we want its mirror point. So here's the axis of symmetry going over 4, and then 4 more is here. This is going to be 8, 8 2/3. So we've got the y-intercept is 0, 8 2/3. Just listing everything off to the left. The y-intercept mirror is 8, 8 2/3. There we go. All right, let's find these x-intercepts. I don't know that it's going to work out any better than before, but let's give it a shot. We've got 0 equals 2/3 times x minus 4 quantity squared minus 2. We'll add the 2 over to the other side. 2 equals 2/3 times x minus 4 quantity squared. Now we could do this in a couple of steps, but it's really nice to multiply both sides by 3/2 to clear that fraction. All right, when I do this, the 3's will cancel and the 2's will cancel. And then on the other side, the 2's will cancel as well. So we'll get 3 equals x minus 4 quantity squared. This one's still not great, but it's a little nicer than the last one. At least I don't have fractions. If I take the square root of both sides, not forgetting the plus or minus, I get plus or minus the square root of 3 equals x minus 4. And I'll add the 4 to both sides, and this will give us x equals 4 plus or minus the square root of 3. So the x-intercepts are the 2 points, 4 plus the square root of 3, 0, and 4 minus the square root of 3, 0. So 4 is the axis of symmetry, and we're moving plus the square root of 3 to the right and then minus the square root of 3 to the left to get those x-intercepts. I'm not exactly sure what those values are, so I'm going to find some other points first. I'm going to say, what if we plug in like 2? Like 2, if I were to think about where is it going to be approximately, it might be around 2 for that x-intercept. So I'll plug that in, see how good that guess is. G of 2 equals 2/3 times 2 minus 4 is -2 squared. And we'll subtract 2 from all of that. This is 2/3 times 4 minus 2. 2/3 times 4 is 8/3 minus, I want to get a common denominator of 3, so that needs to be a 6/3. 6 over 3 is 2. So this equals 2/3. That's not bad. That's just a little bit above the x-axis there. So 2 2/3 is here, and then it's going to mirror across to 6 2/3 over here. 2 comma 2/3 and 6 comma 2/3. All right, we've got 5 points. Let's go ahead and draw in our parabola. This is not the best parabola I've ever drawn. So let's cut in a little bit. That's not y equals g of x. All right, now I'll go ahead and label my x-intercepts. Got them here and here. And so the first one, this is 4 minus the square root of 3, comma 0. And then this one on the right, this is 4 plus the square root of 3, comma 0. That's our two x-intercepts. All right, I hope that was helpful and that you guys picked up on that idea of kind of figuring out where those x-intercepts go without using a calculator. Honestly, I am totally fine if you plug those in and get a decimal approximation to them. I just want to show we don't have to use that calculator all that often once we get comfortable with some of this stuff. So, and I know that's a learning process. All right, everybody, thanks so much for watching. That's it for this video. And I will talk to you here talk you through in a couple more videos after this one. Thanks again, everyone. See you soon. Bye.